ಆಯಿತು, just a minute. Perfectly oriented. No more corrections now. Let a minute over. Okay. I don't know today how come perfectly came today. No turning, no tilting, nothing. Good evening. Slightly adjust it. Okay. Nothing required. Just let me know. The board is clear. Voice also fully clear. Board is clear. Voice also fully clear means I will start. Voice also okay. Just I'll check the boundary here first, up to where I can write. So that, okay, up to here I think. Maybe. Yes. That dot you can see. Okay. This side. Little more. Okay, here. Okay. I think I want a little upper side for writing the beam. So I'll slightly push the camera down. Slightly I'll push the camera down. So that this dot is visible. That dot visible. 1 minute. So that because upper side I can put the beam. Because you can project down and go for MD and Kani. 1 ನಿಮಿಷ ಆಗೋಯ್ತು. Slight shifting. Yes, now I can see it. Okay. So we are starting. In case not visible, let me know immediately. Just I'll put some number here. 17.8. Okay, visible, correct? Okay, start now. Now we'll start the two important one. See, first of all, make a note. The very purpose of this class, which one? This revision class or explanation of all the concept, it is very important. SD method, nothing. First of all, yesterday class, it is already known. There is no confusion. Tell me where you get that confusion. Actually, where problem? Not SD method. SD method, there is nothing. So, for SD method, mechanical. If the slope is there, put theta. Overhang, you put only mxy, could mrxy. Wherever unknown is there, form the equation and solve. So, difficulty is for MD method and Kani's method. Tell yes or no. Difficulty is for MD method and Kani's method. Just tell me yes or no. MD and Kani confusion. Yes. Therefore, start. I will do simultaneously. See. Before you start MD method and Kani's method, first I will give you small information. See. This I will not keep on telling every time now. For both moment distribution method and also Carney's method. Remember, moment distribution method, you require distribution factor D. You should write. I am not writing what is D. I am telling here. You require distribution factor D. Those who want should write it here. You should tell, sir, you wrote D. You did not tell what is D. What I am not telling here now. Okay. And Carney's method, we want rotation factor R. Okay, now, see, moment distribution method, distribution factor, Carney's method, rotation factor. Now, at any joint, consider two members, or first of all, members you leave it, general. At any joint, see, distribution factor for any member at that joint, this is for moment distribution, equal to, you can either use absolute stiffness or use relative stiffness. Both are correct. Those who are, so many people are using absolute. If they use absolute for far end fixed, they use 4 EI by L, and for end hinged or simple support, they use 3 EI by L. This is not wrong, 100% correct. But you don't want to waste the term E actually, because in all building frames you don't get 3 EI by L. You always get 4 EI by L. So to save the time, somebody imagined you can use, this is if you use absolute stiffness, or I will tell capital K, or you can use relative stiffness, small k. Then when far end is fixed, it is simply I by L. Divide both by 4E. When you divide by 4E, I by L, and for hinge or simple support, it becomes 3/4 of I by L. Both are same. See, 4:3 is 1:3 by 4. Clear? Ratio counted here. Value not counted. 4:3 is 1:3 by 4. Therefore, whether you use absolute stiffness or relative stiffness, factor will come same. Sometimes people will tell, you are using I by L. Sir, books they are given, some books they are given 4EI by L. If they use 4EI by L, other one they use 3EI by L. If I use I by L, other I use 3/4 I by L. Both are same. Okay, done. Now, further, distribution factor at any joint equal to, see, I am using relative stiffness. Either use relative stiffness or absolute stiffness, or I will do one thing, I will put stiffness. Your choice is stiffness of that member. Stiffness of that member for which you want distribution factor divided by sum of stiffness of all members meeting at the joint. Over. This is for distribution factor. Okay. Now, just make a note. At any joint, sigma D is always equal to what? Tell me. Suppose two members are using. One of them, if you get 1/4, other you get 3/4. If one is 2/5, other you get 3/5. Tell me sum of distribution factor at any joint. Sum of distribution factor always equal to. See, distribution means whatever comes you give back. Nothing to hold back. How much? Sum of distribution factor. What is sum of distribution factor? You are not answering. Sum of distribution factors at any joint. This you know it. 1. It is always equal to 1. Okay. 1. Okay. Now I will give an example. Now same way, if you go for Carney's method, same principle, instead of distribution factor, we want rotation factor R. The formula is same formula. Remember, whatever is there right here, transfer here. Relative stiffness of that member divided by sum of relative stiffness of all the member extra into minus half. So, if you can find D, you can find R. Suppose, imagine you get D 3 by 7 and 4 by 7. Or you will get denominator will become double, minus 3 by 14 minus 4 by 14. It will come that way. So these all we solved for 9 questions. You should know it, but I am telling because since I am explaining the method briefly, clear? So those who can find distribution factor, they can find rotation factor. Clear or not? Anybody who can find distribution factor, he can find rotation factor. Okay. Then next, one important note. Now see, this all you have to make a note. This is regarding distribution factors. I told sum of distribution factor is always equal to 1. Now, one important note. See, I'll remove this one. Little. Second important point you should remember is in case of continuous beams, you get overhanging cases. Overhang cases. Suppose there is a overhang here or this side overhang. So, for example, I will tell A, B, some supports are here. Some supports are here. A, B, C, D, E, F. Then, this I told this is called simple support. Simple support with overhang. See, here all you have to find distribution factor by a principle. Both side value will be there. But this is only for moment distribution method. At the overhanging support, you know that, see, suppose you come to B. Tell me, stiffness of BA, how much answer? Stiffness is 4EI by L or 3EI by L. Relative stiffness equal to I by L or 3/4 I by L. That is when far end is fixed or hinge or simple support. When far end is free end, how much stiffness I told you in the class? How much I told you stiffness? When far end is hinged end, free end, what is the stiffness I told you? Stiffness of member if far end is free. How much I told? I told earlier, when the far end is free end, stiffness equal to, why this much delay? You have to answer part, 0. Stiffness equal to 0. Therefore, see here, distribution factor for BA, overhanging side equal to stiffness of that member is 0 divided by 0 plus stiffness of BC. Okay, or do one thing, I'll put here now, see. Distribution for BA equal to KBA divided by KBA plus KBC. KBA is 0, KBA is 0. Therefore, undoubtedly 0. Same way, distribution factor for BC equal to KBC divided by KBA plus KBC. KBA is 0, so it will become 1. Therefore, remember, at any intermediate support, you get distribution factor fraction 1 by 4, 3 by 4, 2 by 5, 3 by 5, 3 by 7, 4 by 7, 3 by 11, 8 by 11, that way. But at the support where overhang is there, I told you in case of beams, not frames. In case of frames, no, because even if overhang is there, this will become 0. Still 2 more members are there. I told in case of beams, if overhang is there, you don't have to calculate distribution factor. See, for overhanging side is 0, inner side is 1. Here, distribution factor for overhang side is 0, inner is 1. Fully clear? Fast. You don't have to worry now. This may not come today, but I will not repeat once again. Full clear? Inner side 0, inner side 1, outer side 0. Okay. This is second concept. Now, rotation factor at the support where overhang is there, we are not calculating because to save the time, shortcut is available. If the overhanging support is given, it is going to be replaced by an imaginary fixed support with 0 contribution. Therefore, there is no calculation of contribution at that point. So remember, MD method, intermediate find distribution factor. Overhanging support, blindly put inner side 1, outer side 0. And Kani's method, at intermediate support you have to find. This I told you just now. How to find? How you find distribution factor, same way rotation factor into minus half. That's all. But at the overhanging support, you don't do anything. Keep quiet. Why? That overhanging support is going to be replaced by imaginary fixed support. This also I told you. Yes or no? Now I won't tell again and again. Anybody can in confusion, go through the class repeatedly. Suppose confusion is there, go through the class again and again. Okay. So that now decide. See, now I decided from now onwards, any course, even I announced a steel class now. I decided last time it was lot of time taken. Now I decided I am not going to tell the same thing again and again because online class, anybody get confusion, they can hear again and again by repeatedly going through. In the class I will tell, confusion means repeatedly go through. Why should I tell again and again? So that way, remember, more than 30 to 40% time can be saved. Because by one drawback, it is not drawback, my habit, what? Telling again and again same thing. Why? Because that is called teacher's instinct. Maybe I will think it is not clear, they might have forgotten it here, so better tell once again that way. But in online class, it is not required, offline required. And so many people are missing the classes there. But here, that is not required. So I am going to reduce unnecessary explanation. Same thing, second time, I decided now not to repeat. Okay, now, one concept clear. Now, 1 minute. Just before you start the explanation, you consider intermediate support. See, I will put the name as O. Why O? O. Let it be one side is 1 member, other side is 2. Okay. Now, see, correct, clear. One side is 1, other side is 2. Now, see, what to do? Just imagine this is 2i, this is 3i. This length is 4 meter, this length is 5 meter. Just for understanding purpose. Imagine. Now, I do not know what is 1 and 2. Okay, stop. First I will tell you. Case 1. You first put the sketch. What you require is, we have to find at the O, we want distribution factor for O1, distribution factor for O2. Same way, at O, we want rotation factor for O1, rotation factor for O2. This is for MD method, this is for Kani's method. Okay, start. Now, I will go for different cases. See, first you put the sketch, you write this much, put one line. Now write once again. Case 1, case 1. Let 1 be, that's 1 be either fixed or intermediate. Remember, if intermediate, tell me, then what? If intermediate, it becomes what? For stiffness calculation, intermediate support becomes what? I told thousands of times. Intermediate supports for stiffness calculation is considered as, thousands of times I told. Intermediate supports for stiffness calculation is considered as fixed. Therefore, let it be either fixed or intermediate. See, either fixed or intermediate. If intermediate, then again considered as fixed for stiffness calculation. Okay, then same thing here. This also fixed. Either it is fixed or it is intermediate. That is considered as fixed. Now, prepare a joint. Our joint is O. Okay, O. Then write members here. Members. Left side member is O1. I will put a line here. Left side is O1. Right side is O1 will do. See, joint is O. O1 or O2. Okay. Tell me what is relative stiffness, that is small k. Remember, I told you relative stiffness equal to I by L if the far end is fixed or intermediate. Whereas relative stiffness equal to 3/4 I by L if far end is simple support. Okay, start. O1. See, when you want relative stiffness, always look at the far end. If you are calculating here, look at the far end. Okay, start. O1, fixed or intermediate. Formula, I by L. I'll write here now. To save the time, I'll write here, I by L. That side also I by L. If I substitute, it will become what? I by L, 2 by 4. 2I by 4. Substitute that side. 3I by 5. Okay. Now, calculate total stiffness. Sigma K. Calculate sigma K fast. 2 by 4 plus 3 by 5. I do not want decimal. I want number only here. Where is the calculator? I will calculate because you will take a lot of time. 2 by 4 plus 3 by 5 is 11 by 10. It is 11I by 10. Therefore, distribution factor will be, see formula, K divided by sigma K. This is the distribution factor. Therefore, answer. This is what? Sigma K that is in between. See, sigma K is 11I by 10. Okay. 2I by 4 by 11I by 10. 2 by 4 divided by 11 by 10 is 5 by 11. This is 6 by 11. Fully clear? In future, I will not explain this one. Fully clear? 5 by 11 and 6 by 11. Clear fully? How to find distribution factor? You have to comment fast. People don't come live. Then you are not answering. Clear or not? Clear. Okay. Now, I will now only tell you if it is Carney's method. Now only. If it is Carney's method. What I told is for MD method. See, Carney's method, you require R. You require R. Only change is into minus half. Therefore, it will become minus 5 by 22 minus 6 by 22 over. This is for Carney's method. Okay. Now, come to now next example onwards. I won't explain for Carney's method because why should I waste time? Whatever you do here, same thing, extra minus half. Okay. That much I can't do. See, now further 3 more cases are there. Further 3 more cases, I will do only for MD. If it is Carney, double the denominator with minus sign. Clear? Fast. Clear or not? Actually, 9 times you are done in the class. Clear? Okay, now start. Second case. Imagine this is still fixed, but this is not fixed. This is simple support. Or I told you something, a crude method. To understand correctly, I should actually use a crude method, but very effective. Simple support means you round off this way. It can be simple support or simple support with overhang, anything. Simple support. The only change will come is, now see, this side. Now this side is I by L, fixed end, same answer, I by L. That side is 3 by 4 of I by L is 3 by 4 of 3I by 5. When you add, you will get 2 by 4 plus 3 by 4 of 3 by 5. It will come 19I by 20. Now if you divide, answer will come reciprocal into 0.5 equal to. This will come 10 by 19 and 9 by 19 for MD method. If it is Carney's method, it will come minus 10 by 38 minus 9 by 38 over. Now, take case 1 over, case 2 over, case 2 over. Take case 3. Case 3, you do one thing. You take this as fixed. fixed or intermediate. Intermediate. But this support, you take what? Simple support. So then, see, simple support left side. This will be rounded off. So when you see rounded side, red color round, then stiffness equal to 3/4 I by L. This will become 3/4. This will become 3/4 I by L. This will become I by L only. So this will become 3/4 I by L. 3/4 of 2I by 5. That will become I by L. When you add, you will get 3/4 of 2 by 4 plus 3 by 5. It will come 39 by 40. 39I by 40. When you divide, you will get reciprocal into 3 by 5. This will come 5 by 13. This will come 8 by 13. Okay. This is for case 3. Now, rotation, Kani's method, minus half extra. Last case, do one thing. Imagine case number 4. This is simple support. This also is simple support. Rounded here. Simple support. Then, that is 3 by 4. This also 3 by 4. This also 3 by 4. Answer will come 3 by 4, 2 by 4 plus 3 by 5 is something into 3 by 4. 33I by 40. 33I by 40. When you divide, you will get same as the first answer into 3 by 4 of 2 by 4. 5 by 11 and 6 by 11. Now, distribution factor calculation for MD method and rotation factor calculation for Kani's method fully clear. Any joint for beams I am telling, not for frames. For beams, fully clear. Either distribution factor or rotation factor. Okay. Over. Make all this note. Okay. Now, further, see what I will do. Some correct order I will go so that all the 9 questions will be clear today. Not a single doubt will be there regarding any concept. But remember, as I told you, you should know how to find the FPMs, how to complete the table in MD method, how to complete the M dash calculation Kani's method. I am repeating again. Table in MD method is told in my own class in Zoom. General public I am not told. They should be knowing it. My class is meant for clearing doubts outside, starting trouble. And Kani's method, if you remember, in YouTube only I uploaded a class. I told all the 9 cases, same type of table. Okay, start. This is also over. Now, make a perfect note. First write, relative stiffness K equal to I by L when far end is fixed or far end is intermediate support, because intermediate support is considered as fixed for stiffness and carryover. Whereas relative stiffness K equal to 3/4 I by L when far end is what? Simple support or hinge. And remember, in moment distribution method, there is a term called carryover. Carryover factor is always half for prismatic member. But remember, carryover will be always to far end. To far end. Tell me answer. Carryover factor equal to half if far end is what? I will not tell again. Is either absolutely fixed or, tell me one more. If it is absolutely fixed, half, or one more. Either if it is fixed or another. Top is not visible. Why? Why top not visible? Huh? Top visible. Who told? Fully visible top. Top not visible. Who told? Fully visible top. Top not visible. Fully visible. Okay. Either it is fixed or it is intermediate. Intermediate. Why? Intermediate support. Reason why? Because intermediate support is considered as fixed. considered as fixed, not real fixed actually, fixed for not only stiffness but for stiffness and also for carryover. Therefore, I will give a firm warning now. You carry over half to far end only when it is fixed or intermediate. And remember, carryover factor equal to 0 when far end is hinged or simply supported. In case of, that is, if it is rounded, clear now? If you round off the support to that support, you should not carry over. Clear? Fast. I will not tell again. Go through the statement 100 times. You should not carry over to simple support. Okay, over. This you remember now? When you carry over, when your hand is moving, you move there with half the value only if it is fixed or intermediate support. If it is a free hand support or simple support, don't carry over. That's why in MD method, if it is simple support, once you release the moment there, tell me what you are doing. Tell me. To ensure mistake not coming, if it is simple support, tell me what word I am using. Once you release the moment there and that fixed end moment is changed over to what? Release the moment. Then what the word I am using? I am going to block it. One red line block. Once you block means don't come back once again here. Okay, over. I will not tell again. Suppose tomorrow someone will ask, sir, it is not clear. Then if it is not clear, go to the statement 100 times. 100 times till it is clear. And further not clear means if they are in the group, then I will tell, then what you are doing all these days. If they are not in the group, I will tell, that's okay, no problem. You learn somewhere else only, where people teach better than me. You search for a person who teaches much better than me. Find him and get knowledge from him only. Okay, now start. Now I am starting systematic order, MD method and Kani's method both simultaneously. Remember, I will not tell how to find distribution factor now or Kani's method. I will not tell how to find rotation factor because 9 times you have done it. And also, how to find FPM, I am not telling. So today's demo class, FPM, I am writing randomly. Clear? I will enter the value. Minus 30, plus 40. Somebody will ask, how you got? How you got, don't answer. Something you are getting, no. Write that value. Today, I am not showing you loading. I don't know what load. Load I am hiding. FPM, I am putting randomly. Clear? FPM, I am putting randomly. You write whatever is FPM. Okay, start. One by one, systematic order. I should do both together, one below other one. Nodi, one nimisha. One below other one. Okay, see, 1 minute. Question number 1. See correctly. Question number 1. See, I will start here. Some space I require upper side. I have to manage the space. Okay. If I write here, if I write upper side, visible for you. Some statement I have to write upper side. Okay. You can see it. Further down I will write. Further because I want space here. Fixed. Question number 1. See now. Intermediate support and intermediate support, and here it is once again fixed. And one more thing, do not by heart A, B, C, D. Okay. See, I will call support A, support B, support C, support D. I always start from left side A. A can be free and also later. Okay, then over. Now, tell correctly. When I explain what? Stiffness and carryover, you should know it. First step what you do is, see here, B, intermediate support, I, therefore considered as what? Tell me, I, arrow mark means considered as. You should write. I won't write, space is not there. When I put arrow mark, it is called considered as fixed. Considered as fixed. Fix, sakbadi. C also, intermediate support. Therefore, considered, sakbadi, considered as fixed for stiffness and carryover. Remember, I won't tell again and again. It is not absolute fixed. Fully visible, or shall I come down? Fully visible or come down? B is intermediate support considered as fixed for stiffness carryover. C, intermediate support considered as fixed for stiffness and considered as fixed. Fix. Okay. Now, come to end support. This is absolutely fixed. Absolutely fixed. This also is absolutely fixed. Over. Fully clear? Then first you do this one. And now do one thing. You should remember one thing. If the support is interfixed or if it is fixed support, remember intermediate considered as fixed. Now I will not tell. Okay, agreed? If any other support is there, then it is better to understand concept. Using red color. Tell me, this question, red color will come or not come? This question, red color will come or not come? This question, red color, will it come or not come? This question, red color is for simple support. And where? See, this is not simple support. This will look like simple support, but it is an intermediate support. The simple support at the end. That is end, large support you should see. This problem, your crude method or red color will not come. I will take other red color so that very dark it will come. I will take a red color which is very, very dark. It was there. Yes, same thing. Problem. When I need, I am not getting it. Okay. Okay, this will do. This question, red color will not come. Okay, start. Now tell me correctly. Nodi. At B, if I put arrow mark here and arrow mark here, if I put arrow mark here and arrow mark here, that means relative stiffness. Nodi. Relative stiffness, far and fixed. I by L. Relative stiffness, far and intermediate. I by L. Come here. Relative stiffness, far and intermediate. I by L. Relative stiffness, far and fixed. I by L. I am not writing. You should write small k. I am not writing that much because my space is not there. You should write that way. Clear? What I wrote is relative stiffness. Clear or not? Fast, fast. Clear or not? Fast, tell me. What I wrote is relative stiffness. Okay, now, with this one, you can find distribution factor at B and C, and for Kani's method, rotation factor at B and C. Okay, start. Next step. Calculation of FPMs. Sorry, I am not explaining. Then, if you are going to moment distribution method, next step is what? Next step is, I'll put here now. See, if you are going for moment distribution method, next step is moment distribution table. Table. How to write table? See here, I am below. Put the table. End support, you write whatever is support. Fix means write fix here. But intermediate support, don't show arrow mark, just put one line here. Just put one line here. Here also, absolutely fixed. Okay, now, A, this is B, this is C, this is D. Here, enter the factor. Enter distribution factor. enter distribution factor. Okay, enter it. Then members your name AB, BA, BC, CB, CD and DC. You write here, these are the members. Then enter the FPMs. Whatever FPM you got, I will enter the FPMs here randomly. See, minus 60, plus 50, minus 40, 42, plus 36, minus 70, plus 80. Okay. Randomly written. Somebody will ask, sir, how you got it? How you got means you calculate and enter random values. Okay, start. Now, first step for moment distribution method is correctly, if you want concept, these are the fixed end moments for the beam. At any intermediate support, compatibility required or equilibrium moment required, that you are maintaining by moment distribution. But end supports, if they are not fixed, you have to apply correction. Remember, this is the correct concept. Or now onwards, easy method. As soon as the table is ready, next step is, I will put end correction. Clear now? Some name required. End correction. End correction is always by releasing. Releasing moment. Clear now? You make a note. First, before you start the distribution, first end, technically I told you, wherever simple support is there, if only one member is there, that FPM should be made zero. Whatever FPM you got, it should be reversed and applied there to make zero and have to be carried over. Or you should ensure that the original condition is maintained there. Intermediate support we do by distribution. Intermediate support by moment distribution. Or that's the correct concept. Or now onwards, correct concept I will not tell. I told already. But remember it as end correction, end support correction, end support correction, end support correction. End support correction is there only for, which one, tell me? End support correction is there only for, which one? Tell me. End support correction, easy method to understand. Crude method, okay, no problem. End support correction is there only for either simple support, when I round off full member, either simple support or simple support with overhang. Then I will do like this, this way. Clear? Or simple support with overhang, or SS should be there. SS means simple support. If you put SSO, that also is simple support only, but with overhang. And the correction for these two is same, but procedure is different. Okay, I will tell you. This question, no end correction. Correct? You make a note. No end correction. Clear? This has no end correction. Clear or not? Fast, don't waste time. No end correction. Yes. Okay. Therefore, if after the end correction is over, then you add the values once. That will be called, sometimes people call initial values or modified FPMs. Okay, whatever you want you can call modified value. But now there is no modified. So directly start. Now what to do, I will not tell. Start. Now what to do? Add the two value, distribute, add the two value, distribute, carry over. Everywhere carry over is there. Wherever I by L is there, carry over is there. Again, distribute, etc. That way, complete the question, add everything, you get finally, the final moment will come here. You get the final moment. Add all the values, get the value here, get the values, then go to star. This class is meant for avoiding confusion, not for procedure. Clear now? Over. MD method, question is over. Clear now? Okay. Now, come to Kani's method. Now see, very careful. If you are going for Kani's method, something important, then same beam, your step will be after finding rotation factor and finding FEMs. Remember, MD method, distribution factor, then FEM, then table. Kani's method, rotation factor, FEMs, and not table, something like table. See, come here. A is absolutely fixed. Then fixed. If it is fixed, see, solid fixed here. Put one box here. All intermediate support, put a box. All intermediate support, put a box. So, pay barbecue. I will provide. Okay. Okay. Space problem, available space. Okay. This way box. Again fixed here. A, B, C, D. All are fixed here. Put a box inside. Put a box inside. I will explain all the in question. Then member name is not required. Upper side, enter F here or not. Here enter respective rotation factors. Enter respective rotation factors. Okay, then upper side FEMs. Okay, I will write FEM here. Minus 60 plus 50 minus 42 plus 36 minus 70 plus 80 FEMs. Then in Kani's method also same correction as MD method. You can do without correction. Then simple support you have to go for rotation contribution calculation. Then minus half will come. Then if you take stiffness equal to I by L there, it will lead to confusion. So 99% people throughout the world, they follow this step. So what end correction is there? See, this is for what? Not only, this is not only for MD method, but also for which method? Also for Kani's method. Clear? The end correction is not only for MD method, also for Kani's method. Clear now? That is called releasing to make the table easier. Okay, start. This time there is no end correction. Therefore, if there is no end correction, no modified FEM. Now start. Add the two FEM here. 50 minus 42 plus 8. 36 minus 70 minus 24. Enter here. Okay, now enjoy and calculate. See, this is your M dash BA, this is M dash BC, M dash CB, M dash CD, M dash DC, this is M dash AB. Remember, where absolute fixed end is there, rotation contribution is real zero. See, real zero. This also real zero. Later imaginary zero will come. Okay, start. Now, enjoy and repeat the terms here. Repeat the terms here. Okay, repeat it. Once you repeat, I am telling you for Kani's method. I will tell you this is for Kani. This is for Kani, Anisha. This is for Kani. Okay. Then for Kani's method, write the formula for finding final moment. The formula is mxy equal to m bar xy. Any member xy, for member xy, any member mxy equal to m bar xy plus 2 times m dash xy plus m dash yx. This is fixed end moment plus 2 times of rotation contribution at that end plus rotation contribution at the far end. But warning, see, warning. Do not apply this formula at which support? Tell me. Since you are modifying, this formula is, see now, do not apply at what? At which support? Tell me. Original. Do not apply at which support? Do not apply this formula at which support? This formula should not be applied at. I told you, if you apply, wrong value will come. Because I proved it in the class also. Do not apply this formula for either simple support, apply, see, do not apply at either simple support or simple support with overhang. Their direct answer is whatever is what? Their answer is whatever is what? Final moment at the simple support or simple support with overhang will be whatever is. What? Tell me. Whatever is. No contribution, nothing. Whatever is. Modified FPM. Whatever is, which one? Modified FPM. Clear? Whatever is modified FPM. Clear or not? Not FPM. Modified FPM. Tell me, clear or not? Whatever is your modified FPM. Fast. I have to complete 4 cases today. Whatever is not FPM, modified FPM. Okay. I won't repeat once again now. Okay. Go through the statement 100 times if you want. Start. Now, this question, member AB, or 1 minute now. Start from here. Calculate MAB, calculate MBA, calculate MBC, calculate MCB, calculate MCD, calculate MDC. Usual method. FPM plus 2 times this value plus forward value. That all I can't tell here. This is not Kani's method full solution. This is confusion removing. Okay. Enjoy. Get the moment. 100% result from Kani's method will tally with the MD method and also will tally with what? In my class, 100% result by Kani's method will tally with MD method and also will tally with which one? And also will tally with my guarantee. I am giving guarantee for you. Also with SD method or also with any method, even matrix method, stiffness method, flexibility method or finite element method, either direct stiffness method, etc., or even strain energy method or constant deformation method, any method you solve by any method, answer tallies. Over. Question number 1, there is no confusion, fully clear. Okay, now start. Question number 2, be careful now. Question 2 is left side fixed support, right side is simple support. Now here see, right side support D is simple support. Oh, now see, first end support D. See, it is round off, full round off. It is simple support with only one member. Okay, tell me, one by one change. I by L, I by L, I by L. This is not I by L. This is 3/4 of I by L. Clear? This is 3/4 of I by L. Clear fast? Tell me, clear or not? Stiffness of CD equal to 3/4 of I by L. Clear? Okay, over. Now, go to MD method. Same table. But see, FPMs are same. I will put plus 80 only here. In the table, do one thing. Intermediate, you just try. See, intermediate, minus 50 plus 50. How much I wrote just now here? I leave it. Minus 42. Okay. This maintain martiyanu. See, now, enter the FPM. While finding FPM, every support considered as fixed. Now remember, in the MD table, if it is fixed, show fixed. If it is simple support, show simple support. Nodi. It is, remember, simple support. Again I will write you. Simple support it is. Okay, start. FPM. First step is release the moment. See, first step is release moment at simple support D, or release unbalanced moment for overhanging case. Only one member is there. Tell me here, plus 80. Net moment here should come 0. Tell me how much you require. Plus 80, how much you require? To make 0, how much you require? Fast. You require minus 80. Put minus 80 here. Immediately half the value carry over here, minus 40. Okay, that's all. Now here no correction, end correction over. Therefore put a double line. After end correction put double line. Okay, now start. Add once again. Write modified FPM. Either call modified FPM or initial values. Okay, remember 0 will come here. Then here no change. Minus 60, plus 50, minus 42, plus 36, minus 110 and 0. Now remember, once you go for modification and add, now later onwards, you should not see any of this value. You should start fresh from here. When you add finally, blindly don't make the mistake. Minus 60, minus 60. You should not see any value above this line. Why? Because this is like account settled. Settlement is done. New account. Clear? Like a new account. Clear or not? This I will not tell further. Now you start from here. New account. Upper side is cancelled. Okay. And also remember, before you start, where you made what? End support, simple support, where correction is there, first block it. Block. How to block? This way. Now, no, blocked. No, full line. Actually not this way. Table will come this way. Fully blocked. So that even if you want by mistake also, you can't carry over. Now, start. That's all. Now, enjoy the table. Only thing is, no carry over this side. See, there now onwards, no carry over this side. Start. Add the two value, distribute. Add the two value, distribute. Carry over half, carry over half, carry over half. No carry over there. Add everything, you get the moment. This will come 0. Fully clear, MD method, fast. MD method, fully clear. If fully clear, I will go to Kani's method. Then take a small break. Clear, okay. Go to Kani's method. When you go to Kani's method, same notes are applicable there. See, what all I wrote here, it is applicable for MD method and also Kani's method. Okay, start. All over now. See, now A is fixed, but D is not fixed. Tell me. In Kani's method, if simple support is there, it is replaced by what? It is replaced by what? Tell me. Imaginary fixed support. Remember. See, this way. Light line. Imaginary fixed support, which is originally what? Which is originally simple support. Correct or not? Imaginary fixed support, which is originally simple support. Clear or not? You write in the table imaginary fixed support because no contribution, but which is originally simple support. You should remember it. Imaginary fixed support will come for simple support only. Clear or not? Fast. Imaginary fixed support comes only for simple support. Okay, start. Now, first step, what do you have to do? Same as releasing. Nodi, plus 80. Only one member is there. Simple support, net moment should be 0. You put what? Minus 80 here. Minus 80, minus 80. Immediately, half carry over here, minus 40 over. Then, what to do is, after, this is correction. Put one line here, add new value. New value will be minus 110 and this value will be 0. So remember, so this is what, tell me, this is simple support, imaginary fixed support, which is originally simple support. Tell me, what are these values? These are modified FPM, correct? These are modified FPM. Yes or no? These are modified FPM. Clear? Revised or modified FPM. Okay, start. Now, start here. 50 minus 42 plus 8. 36 minus 110. It will change now. It will be 36 minus 110. 36 minus 110 will come minus 74. Okay, minus 74. Now, enjoy the table and repeat the values. Now that for everybody public, one question done earlier in YouTube only, refer that one. Okay, now last step, calculation of final moment. Tell me, which point you should be extremely careful. When you find final moment, tell me which point you should be extremely careful. Which point? A, B, C, D. Tell where you should be careful. D. Therefore, see, moment at D, you should be careful. Remaining values, happily find. Happily find means what? Now onwards. Happily find means FPM 2 times this value plus far end value. Happily find. And at simple support D, final moment, see, be careful. Do not apply Kani's formula. Tell me, what is the modified FPM there? Tell what is the modified FPM there? What is the modified FPM there? What is the modified FPM there? That itself is final moment. Ready? 0 over. This question number 2 is over. Fully clear? Question number 2 over. I will finish 3 fast now. Then I will take a break. Why? Not much time. Question number 2. Fully clear? Question number 2. Fully clear. Okay. Question number 3. To save the time, I will go to question number 3 now. Question number 3 is, see, simple support here. Whereas fixed support here. This is D. D is fixed support. So, now I by L, this will be 3/4 I by L. Correct? This will be 3/4. This A is simple support. Remember, simple support. This is 3/4 I by L. Now tell me, in the table, release moment at which point? Tell me. Now in the table, release moment at which point? Tell me answer. In the table, release moment at which point? Moment at A. Release moment at A. How? Minus 60 is there. Put plus 60 here. Make a red color. Plus 60. Carry over half here. Plus 30. Add it. 0 will come here and block. No more carry over this side now. This will come plus 80 minus 42 plus 36 minus 70 plus 80 modified. Now remember, no more carry over this side. Never carry over here now. Now distribute, carry over, distribute, carry over, distribute, do this one, do that one. Enjoy the table and get the final moment and go to star. Over. Kani's method. Remember, same note. This is 3/4. Right. Once again you have to copy the question. Don't do correction there. Now, Kani's method. See. Now, support D is, sorry, here. Support D is absolutely fixed here. This is absolutely fixed. This is real 0. This is real 0. But support A will become what? Support A will become imaginary fixed support, which is originally simple support. Remember. Therefore, this is imaginary 0. Tell me. Now, tell where correction. correction not D, correction at A, put plus 60 here, carry over plus 30 here. So it will become plus 90 here. This will become 0. And resolve will remain same. 36 minus 70 is 36 minus 70 minus 24. Here 90 minus 42 will become 48. Okay. Now this is 0, that is real 0. Enjoy the table. Okay, start. When you do final moment, tell me where you should be extremely careful. Tell me, when you do final moment, where you should be extremely careful. Where you should be extremely careful. A. So, A is simple support. See, at A moment is MAB. MAB. Be careful. MAB equal to modified FPM there. 0. Over. Remaining all enjoy by Kani's method. Remaining all moments enjoy by Kani's method and happily get the final moment. Result will tally with the MD method and Kani's method. Close the question. Over. Question number 3. Next. Question number 4 I have start now. Question 4 is A is simple support and D also simple support. Nodi. D. A is simple support. Even D also is simple support. This is also simple support. Therefore, see, this is 3/4 I by L. This also 3/4 I by L. Therefore, this time, tell me, this time, release moment where? Tell me. This time, no, here you should write what? Simple support. Remember, simple support. This time, release moment where? This time, release moment at both A and D. Come to A, make it minus 60 is there, make it 0, plus 60, carry over half here, plus 30, and then last here, plus 80 is there, make minus 80, carry over half here, minus 40. Now, when you add 0 will come here, when you add 0 will come here, block this one, block this one. Now, no more carry over this way, no more carry over this way. So, this will change 80, 42, 36, minus 110 over. Now, distribute, enjoy the problem, get the final moment. Okay. Go to Kani's method. When you go to Kani's method, same way. Once again write the sketch, don't make mistake. Then tell me, in Kani's method, tell me, I forgot, tell me where release required. Tell me, in Kani's method, where release required? Where release required? See, this time in Kani's method, this is imaginary fixed support. This also becomes what? This also becomes imaginary fixed support. Fixed support. And this is 0 contribution. Release required at both A and D. What to do? Plus 80 is there, minus 80, carry over half here, minus 40. Here, already done. Plus minus 60 is there, put plus 60, carry over half. Add it. Then you are getting, see, add it. 0, 90, this will remain same. You get the modified FPM. You get the modified FPM is how much here? Minus 110 and here 0 over. Now, when you write here, it is 90 minus 42. It is same. Plus 48. I think illi 36 minus 110. Martoitu. Forgot it. Forgot it. Minus 74. It is minus 74. Now, this is 0, that is 0. Over. Enjoy the Kani's table. When you find final moment, lastly, tell me where you should be extremely careful. Where you should be careful. Not apply Kani's method. Not apply the regular formula of FPM plus 2 times this contribution plus foreign contribution, you should not apply at simple support. Where, tell me? Where? At A and D. So, at A, moment is MAB. Nodi. Be careful. Careful. At D, moment, simple support. Here also be careful. Careful. At the simple support, whatever modified FPM is there, that is the final moment. Here also, see, 0, 0. Remaining, enjoy by Kani's method. And complete the question, get all the values. Complete the question, get all the values now. I drop the pen. Complete and find all the values for remaining. Now, fully clear, fast. Fully clear. Fully clear. Now, beams with both end fixed. That side fixed, this side simple support. This side fixed, that side simple support. Or both end simple support. Complete this one. Fully clear. SD method, MD method, Kani's method. Okay, fully clear. Now we are going to overhanging case. Overhanging case. Already better. I think I got little work now. 9 o'clock I have to go. 10 minutes time is there. I first thought I will finish in one class. No, I told so many concepts for you. Do one thing. What I will do is overhanging case. See, this much I will not repeat. This will be still there. I am not removing for tomorrow's class. Tomorrow the statement is still there. These all will be as it is. I don't have any other class. But table will change. So, got little work at 9 o'clock. So, 10 minutes I can't do anything. I have to hurry. No. Overhang you cannot hurry. Tell me, if at all confusion is there, it is more for simple support, ordinary or overhang. Tell me, if at all confusion comes more, it is for simple, ordinary simple support or with overhang. Tell me, if at all confusion comes, it comes for what? Ordinary simple support or simple support with overhang. With overhang. So, with overhang, tomorrow we will fully complete. How many questions? Tell me, how many questions? Not 4. Left side fixed, right overhang. Left side simple support, right overhang. Right side fixed, left overhang. Right side simple support, left overhang. Both sides simple support. Tell me how many questions? Hurry. Both side overhang. Not 4. How many questions are there? 5. No problem because today 4, tomorrow 5. But no problem because tomorrow around half an hour or 30-35 minutes I explain distribution factor etc. That is not required tomorrow. So tomorrow I can directly go to overhang. I will prepare a big sketch for overhang. Both method, complete clarification I will give tomorrow. Agreed? Okay. Tomorrow complete clarification for both methods. After tomorrow's class, in future, you should never worry about SD method, MD method or Kani's method for any type of beam. Frames I will take in the class only. Okay, thank you. I thought of taking a break. Then I saw the time approaching 9 o'clock. I thought, no. If I can tell one overhanging now. But no, let it come in a stretch only. Otherwise, tomorrow class someone will come. They will tell not clear. So, therefore, everything half today, half tomorrow, little 10% today, 90% tomorrow means better 90% to 100% tomorrow only. Okay, thank you. Everything told so far, thoroughly work out. Now do one thing. Now go back to the 9 questions we solved in the class. Agreed? Now go back to the 9 questions we solved in the class and go through first 4 questions. Agreed now? Now go back to our class 9 questions and go through first 4 questions. Okay. It will be tomorrow you will tell crystal clear. After tomorrow's class, finish another 5 questions. Next class onwards, you should tell, I have no confusion, no difficulty, nothing is there, correct concept is clear, even crude method also clear. Okay.